Alright, for synthetic division to be used, what we are dividing by, or the divisor, needs to be in the form x minus r. Okay? If it's got an x squared, or y to the third, or something other than an exponent of 1, we can't use it. And then if there's a coefficient in front other than 1, you might be able to use it, but you'd have to divide the numerator and denominator by that number so that the divisor is in the form x minus r. So here's an example of one where we could use synthetic division. So this is the way that I set this up. So you're going to take the coefficients of what is being divided, so the dividend. So in this case, that is our first expression. And I'm going to lay them out as so. So the coefficient of y to the fourth is 1. The coefficient of y to the third is -3. Coefficient of y squared is 2. Now you want to make sure that you leave that you could put a coefficient for every single descending spot. So there's a 0y in here that they didn't write down. So we need to make sure we leave a spot for that. So I'm going to put a 0 for the y spot, and then -20 for the no letters spot. Now the book likes to write the upside down division thing around what we're dividing by. I like to do it around what we're dividing, just so I know what's being divided. But you can do it the other way if you want. And then you're going to divide by r. Now r in this case is going to be 5, positive 5. Okay, because you notice, because in the divisor, the form x minus r, that means we change the sign of r. So I'm going to divide by 5, or what we get when we change the sign of -5. So first step is to bring down the first coefficient, which is 1. Now you're going to multiply the 5 by what we just brought down. So if we multiply 5 times 1, we get 5, which I'm going to place below the -3. Now I am going to be adding the numbers I get underneath my original coefficients. So when I add -3 and 5, I get 2. And then again, we're going to multiply the 5 and the numbers we get down here. So 5 times 2 is 10. So I will write down 10 underneath the 2. And I'm going to add those two numbers together to get 12. Multiply again by the 5, and that gives me 60. Plus 0 is just 60. Times 5 is 120. Plus the -20 gives me 100. Okay, so I am done doing the computations. Now I need to write them back into the polynomial form so they look something like this again. So remember, when we divided our original expression, we had a y to the fourth, and we divided by just a plain y. So if we think about that, just kind of off to the side, a y to the fourth divided by y would give us a y to the third. So on synthetic division, your first variable exponent will always be 1 less than the original highest exponent. Okay, so when we turn these back into polynomials, I will get 1 y to the third, and this was a positive 2, so plus 2 y to the second, because we're going down, we're descending with the exponents and the variables. And then we'll have plus 12 y to the first, plus 60 y to the 0, or just no y's. And then 100 is my remainder. So we will add 100 over the x minus 5, which was what we were originally dividing by. So that would be your answer, or your quotient.